So in this video we will be talking about nuclear binding energy. Now if you look closely, if you look at the mass of, say suppose mass of neutrons, mass of neutrons, mass of protons and mass of electrons. If you sum up all of this, you should have the total mass of that particular element. Now say suppose if you're talking about a oxygen, a O2, if you're talking about oxygen, so this is 16O8. So 16 is its mass number. This is its mass number. 8 is its atomic number. Now if I put all of this over here, mass of neutron, how many neutrons are there? There are 8 neutrons. 8 into what was the mass of neutron? That is 1.008666 atomic mass unit. If I talk about the mass of protons, I have 8 into 1.00727 atomic mass unit. And if I talk about the mass of electron, which is actually very negligible, it is equal to 0.00055 U atomic mass unit. So now if I add all of this, therefore the expected mass of all of this should have been equal to around 16.12744 U. But what we actually see while looking at, by using spectroscopy experiments, what we actually see, now we won't be discussing in detail about spectroscopy, but it's a method in which you can find out the mass, the actual mass of a particular element. So the actual mass of oxygen comes out to be 15.99493 atomic unit. So now there is this question as to why. Why is there a difference in the mass? And with this question, we come to the concept of the mass defect. Because initially it should have been this, but the actual mass is this. So now we come to the discussion of mass defect. And this mass defect, del M, is given by Z mass of proton plus atomic mass minus Z into mass of neutron, and this is whole divided by the actual mass. So the mass defect is given by this particular formula, where Z is the atomic number, A is the mass, atomic mass minus mass, then this is the mass of neutron and this is the mass of proton. So this is what we can understand from the mass defect. Now why is this a mass defect? Now the question is, where does this extra mass goes to? So we have a deficit of this extra mass, and now we can further bring in the Einstein theory where mass has been converted into energy, that is mc square. So in a way what we can say is, this particular mass that is not there has been converted into a energy, and this energy is required to bind all the protons and neutrons together in the nucleus. So it is this binding energy. This is this binding energy that we talk about. So now what you can understand is E binding is actually equal to the missing mass into C square. So now if you want to understand this physically, what you can understand is, say suppose you have different neutrons and different protons. Now, if you want to bind this together, you will bind this. So, a energy of EB, binding energy, will be released. So, after that release, you will have the incomplete nucleus. Now, if you want to separate this nucleus into its respective protons and neutrons, you will need the same amount of this binding energy EB. So, this is what we can understand by the concept of binding energy.